result of subtraction as a multiple of 7. So let's look at 3 and 73. 73 minus 3 is equal to 70, and 7 divides 7. That's enough to say that 73 is congruent to 3. What's another number that's congruent to 3 mod 7? We have that 10 is congruent to 3 mod 7. Is this, well, wait a minute. Is 73 congruent to 10 mod 7? Yes. Well, yes, we have 73 minus 10, which is 7 times 9. So another way that you could say this that would be equivalent is instead of saying if n divides a minus b, you could rephrase this as if b minus a is a multiple of n. And that might make it a little bit easier. If you subtract the two numbers and it's a multiple of whatever your modulus is, then they're congruent modulo that modulus. This number is called a modulus. The number that you're taking congruence with respect to. So we have an alternative definition here that might be a little bit easier to think about. Like, what are some examples? Just recognizing these things are congruent. Let's jump back from 7 for a minute. Let's look at n equals 2. So if our modulus is 2, can you give me two numbers that are congruent to each other mod 2? 8 and 4. So 8 is congruent to 4 mod 2. With 8 minus 4 equals 4, equal to 2 times 2. What are two other numbers that are congruent mod 2? 9 and 3. Can you tell me why? So another way that you can think about this, although it doesn't lend itself to a definition, a clock where you start at 0 and you go to 1, and then when you get back around to 2 is congruent to 0. 3 is congruent to 1. 4 is congruent to 2 and 0. 5 is congruent to 1. What time will it be 24 hours from now? It'll be the same time. Time works mod 24. You reset every 24 hours. So when you work mod 2, it's like you have a clock where there's a 0 and a 1, and then you just keep doing your numbers around. You start writing out your integers. You're going to have 0, which is not congruent to 1, which is congruent to 0. You're going to have 3, which is congruent to 1, 4, which is congruent to 0, and this pattern will just repeat. You all see what we're doing?